All right, it's a pleasure to begin our second session on high-performance computing. And I'll introduce Brian Wilson. He's the director of the Energy Institute. He's been at CSU for a while and been incredibly successful. I think he bought a building on the Poudre River for $1, and you know what it's become today. And so that's the kind of success I think we want to emulate. And Brian's going to introduce our first speaker after telling us a little bit about this larger problem of energy and AI, and how do you solve problems with constrained energy, and how do you do work without having a nuclear power plant.
Or maybe having nuclear power.
Good afternoon. Again, Brian Wilson. I direct the Energy Institute here at Colorado State University. And the Energy Institute is a campus-wide construct to accelerate the work we're doing in energy. We have over 200 faculty members working broadly in energy and part of the Energy Institute, mostly in science and technology, but also in policy. So former Colorado Governor Bill Ritter has established an energy policy center that's now part of the Energy Institute. We have faculty members in psychology, sociology, anthropology, working on behavioral aspects of energy. We have an energy humanities program, so it's quite comprehensive. But we also have a physical facility, our Powerhouse Energy Campus, and Michael alluded to that. I came to the university in 1988, so 37 years ago. There was a shortage of lab space, so by 1992 I still didn't have a lab. For those of you in the university world, you know that you have 6 years to get tenure. Being 4 years into that without a lab is a nervous place to be. Was looking at creative options because I had contracts in hand and no place to set up to work. And we had an abandoned power plant about a mile from here, and what was then the bad part of Fort Collins, which is now turned out to be the cool part of Fort Collins. So, abbreviating the story, but yes, we wound up owning a former coal-fired power plant. We've now expanded. Original building was 35,000 square feet. We had later added another 65,000 square feet, so 100,000 square feet. It's the largest dedicated energy research facility at a U.S. university I'm aware of. And we're in the planning to expand that and add hopefully an additional 165,000 square feet. So, going back in the Wayback Machine, the first contract I got when I was here as a young assistant professor was in 1989 to look at applications of artificial intelligence for engine control. And at the time, it was using these newfangled things called neural networks that to look at data coming from engines, and sort of said, it'll never work. We wound up ultimately, but we also chose our application well. We chose to work on industrial engines because it's really hard to move innovation into the automotive industry. And we continue to that work on industrial engines. In fact, today, Caterpillar's chief engineer is at the lab. And I can tell you that the primary thing on his mind and sort of everyone else's mind right now is energy for data centers, energy for AI. So I've done a lot of traveling in the last few weeks, mostly trying to figure out what's happening in our federal government and the chaos and what that means in terms of our research enterprise. But from March 10th through 14th, I attended CERAWeek in Houston. CERAWeek is a big meeting of primarily oil and gas companies. And Energy Secretary Chris Wright spoke there. And his primary themes were energy for AI, AI for energy, and LNG exports. A couple weeks later, March 17th, I attended the RPE summit. RPE is the Advanced Research Projects Agency for Energy. It's the high-risk, high-impact part of Department of Energy. I was actually a program director there from 2012 to 16 on loan from the university. And Chris Wright spoke at that meeting. And he talked about energy for AI, AI for energy, and innovation. Next week, I will be in Oklahoma City at a small event hosted by Oklahoma State University. It's useful to know that's at the Harold Hamm Center, and Harold Hamm is the guy who championed Chris Wright to be Secretary of Energy. And I'm anticipating the themes will be energy for AI, AI for energy, and drill, baby, drill. But some interesting things that, well, maybe back off on this and talk about the kind of relationship of energy and computing. Many of you, I was just talking to Thomas about the power use effectiveness at data centers. Maybe you are aware of PUI. It's basically the total energy use of a facility divided by the theoretical energy used to do the computation. The average data center is about 1.58, 1.6, meaning that you put in 60% as much energy to cool the facility as you do for the computation. Now, he mentioned that the new data center up in Wyoming will be 1.1, which is really a commendable number. The agency I was at, RPE, has done quite a bit of work on funding better ways to do cooling of those chips. But really, if we're thinking about the energy use, we really need to be thinking about it in terms of efficient computational hardware. The energy use per flop. We need to be looking at efficient algorithms. And then we do need to be looking at cooling and energy management in the facility. But a couple of things I just wanted to repeat that I heard at various conferences and CERAWeek, just some numbers that I didn't know. One is that there'll be 6,000 data centers by 2030. Second, and you guys may or may not agree with this, but is that I think this is from Google, that ChatGPT uses 10 times the energy as a simple Google search. And we certainly know, we see the increased adoption of that. We are anticipating that over the next 10 years, power demand will grow 6 times faster than it has over the previous 10 years. And that's almost entirely driven by data centers, hyperscaling, and AI. So the total growth over the last 20 years was 9% over those 20 years. The load growth over the next 20 years will be 60%. So going from 9% to 60%. So the question is, obviously that has huge impacts on climate, on energy access. So it's really up to the folks in this room to figure out how we can do that more efficiently. Well, maybe I'll mention, so we do work on big stuff. We work on big megawatt scale engines and turbines. And those have turn out to have a huge role in data centers. Even if you've got grid power or power from renewables, if you've got any intermittency at all, you need backup power, and so that can be megawatts and megawatts of engines and or gas turbines or some combination of UPS battery systems, and that can run you for a few minutes to maybe an hour. But then if you've got an outage, then you actually do need to burn something. And in the ideal world, it would be something renewable like hydrogen. We do a lot of work on hydrogen engines and gas turbines, but you do need fuel and combustion for backups. We're really probably the only place. We've got a 1.8 megawatt Caterpillar engine in the lab. We've got a 3.5 megawatt solar gas turbine. And if you've been following anything right now about power system, it's like, where do we get gas turbines? It really reminds me of what happened back in COVID, where everyone was trying to get hold of cars, used cars, new cars. So that's the crunch we're feeling right now. It was interesting at CERAWeek, what we heard from CERAWeek 2 years ago. Everyone was talking about we need power, and it needs to be renewable. Last year it was we need power, and we'd like it to be renewable. This year the thing is we need power. So we're really backing off because the current backing off of some of the requirements on renewability and sustainability of those power sources. So I would just emphasize that the best thing we could do is to reduce the energy required for computation. No question, the use of advanced computing, hyperscaling, AI is going to increase. So we need efficient hardware, efficient algorithms to make that happen. So this afternoon we've got a great discussion from some experts in the field, talking to you about what they're doing on the in sort of the data science and data center side of things. So our first speaker today is Penny Atkins, who's Associate Director of the One Utah Data Science Hub. Penny and I just met, but I've got a paragraph on her, so we're now best friends. But the Data Science Hub, which connects the Data Exploration and Learning for Precision Health Initiative and a number of other educations at the University of Utah. So it builds, maintains world-class data science infrastructure, assures equitable data and infrastructure access, and accelerates regional impact and research. So with that, I will turn it over to Penny to talk about about her work.
Thank you all for your patience, and thanks so much for the tech support. Unfortunately, I can't answer Brian's questions of how we address some of the energy issues, but I do want to talk a little bit about what we're doing in Utah. I think we have a kind of a unique perspective on how we're approaching cyber infrastructure, both for AI and for high-performance computing. So hopefully this is informative and exciting, but I'm going to start with a brief history of Utah's kind of computing excellence history. So if we look back all the way to 1965, this is when we established our Department of Computer Science. So this was fairly early in the days of computer science departments. Kind of fast forward a few years, we were the fourth node of the ARPANET. So this was the first node that was outside of California. And then fast forward about 20 more years, and this is when we established our Utah Supercomputing Institute. And in parallel, the same year, IBM, we installed a 3090-600S, which I don't know a whole lot about those systems, and maybe some of you do, but this was a pretty state-of-the-art machine at that time. It was about a $22 million investment, which in comparison to our $28 million research budget for the entire state, was a pretty large investment. And so this was something that was partnership both between the state, the University of Utah, and IBM. And then in 1994, we established our Scientific Computing and Imaging Institute. This is Chris Johnson. He's the original director and still works at SKI with us. And our Utah Supercomputing Institute became our Center for High Performance Computing. And this was largely in line with kind of the national switch to the idea of high performance computing. We then continued to develop, moving more from turnkey solutions to designing our own. In 2009, we deployed a protected environment, so this allowed us to do the HIPAA-protected data. We operationalized our Science DMZ in 2011, became a service provider in 2014, so actually providing services to faculty across, or researchers across our campus and across the state. Replaced our protected environment in 2017, and then are now working on the Secure Enclave for CMC today. what I wanted to highlight from that history is that in 1989, this article was written, but you could say many of these same things today. Partnerships are really vital to our competitive economy, especially when we're talking about computing. I highlighted two different quotes from the article because I think they describe a little bit about where we as Utah are today. For this first one, it ends with this idea of no company, not even include your favorite corporation, no university, no government can do it alone. And I think this is how we've approached cyber infrastructure clearly for the last 35 years. The second one highlights this idea of why IBM chose to put that supercomputer in Utah. And it's this idea of bringing in our research capabilities from the University of Utah, the willingness of the state government to be involved, opportunities to involve local industry, and then the personality of Utah researchers. So I think very similar to what you have here at CSU, I think that it's really that kind of research collaboration and ecosystem that is also important, but it's this partnership across various entities. So when we talk about what we're doing for computing, a lot of what we're doing is actually translational computer science. So we have some kind of real world problem. We've heard about a lot of really interesting computer problems so far today. You define this problem, you propose some solution, you may prototype it, and then eventually publish. This often results in code and data if you're good at sharing your data openly. Obviously, publications, I think that is very much the literacy that we speak as academics. And then sometimes you might commercialize. But one thing that's often missed is kind of this loop back where you're engaging the community, evaluating and refining what you're doing, and ensuring that it's meeting those societal needs. And so highlighting this kind of tradition that I highlighted of our history of computing, we are continuing that. So we still have our Center for High Performance Computing, and this provides storage and computing resources not only for the University of Utah, but also Utah State University, as well as universities, most of the public four-year institutions across the state. And we're continuing to build kind of the population that uses that environment. We have a protected environment and now the secure enclave, and a downtown data center that really provides all of this. So this provides a lot of the computing infrastructure for the state. In the center column, we have SCI, so this is our Scientific Computing and Imaging Institute, and it also hosts our 1U Responsible AI initiative that I'll talk about a little bit later. And this really supports multidisciplinary, transdisciplinary, translational research focused on research computing to ensure that we can kind of explore new novel solutions. And then on the right, I have our Hive. So the Hive is our research data repository that's run out of our libraries at the University of Utah. This is a growing resource. I think that there are a lot of domain-specific repositories, but they don't always work for every project. So this is an offer that we have. We have research data librarians that support ensuring that data is put in there properly so that it can be shared and reused. I think that they're really working on how to ensure that their metadata is fair, as well as developing provenance of all the data. So kind of stepping back to the SCI Institute, again, this is focused on a really transdisciplinary research and development. Where all of our faculty have an academic home that's outside of our SCI Institute, so we're bringing together different expertise to kind of do interesting computational work. Within SCI, we also have our 1U Responsible AI initiative and our Center for High Performance Computing. So this is really bringing together a lot of the really important initiatives that are moving forward at the University of Utah. And I think one of the most important things, and I believe Jingjing mentioned this as well, is the idea of people and community. And so ensuring that we both have that loop to talk to our community, but support our cyber infrastructure professionals. I think they are so critical to this, any idea of high performance computing or AI. We need to have this expertise. And so we also have a co-op within SCI. And because of the importance of this, I think our 1U Responsible AI initiative, this was launched about a year and a half ago. It resulted in a $100 million investment from our university president, really towards the idea of advancing translational AI to achieve societal good. So this is looking at things when we're talking about responsible AI, I think part of that is the energy consumption and being aware of that, but also ensuring that we're protecting privacy, civil rights, civil liberties, promoting fairness, accountability, and transparency. And so we focused on 3 initial research areas for this: environment, healthcare and wellness, and teaching and learning. And this aligns very much with the priorities that were at HP earlier this morning as well. So within each of these areas, what we wanted to do is leverage existing strengths and combine that with kind of cutting edge AI technology. So looking at AI-enabled resilience solutions for the environment, which we've heard about today, but looking about how we can prevent or mitigate the results of environmental hazards. For health data, one of the very unique things that we have in Utah is an integrated medical school. So being able to leverage some of those unique data sets that we have and bringing that back into something where we can leverage technology to investigate that. And then rethinking education. I think that this is something that we're all trying to understand, is how we educate for the workplace of the future and how we ensure that our students are informed about AI. So our approach for the RAI is really focused on 4 main things. Advanced cyber infrastructure is an obvious one. You can't do anything without the cyber infrastructure. This includes the GPUs, compute, storage, as well as the people to support these programs, and is really critical to anything that we're trying to do with AI. We're building out research expertise, noting that this is really the way to bring in new talent. Part of this, we have a few programs. If anyone's looking for a postdoc, we have a postdoc program through this. We also have a program to bring in experts from industry, academia, or government to come be integrated with our facility and start new collaborations so that we can collaborate with institutes like CSU. So that's a great opportunity. If anyone's interested, happy to talk about it. We do a lot of community engagement. I think that this is critical when we talk about the trustworthiness of computing, and some of the new techniques that we're doing is that if we don't engage the community, they won't trust what we're doing. And so I think that this is something that we're very focused on. We've done partnerships with the libraries. We have a number of different community groups that we also support. And then finally, services and support to really support everything that we've set up and ensure that this is a sustainable effort. So probably what we care about the most here is our cyber infrastructure. So with the Responsible AI initiative, as I mentioned, one of the big investments is towards improving that. So we have this long history of CHPC and SKI, but you can see that with a $5 million investment, we're able to really take our high-end GPUs to 9x what we previously had, take our mid-range GPUs to 4x, and then really increase our storage with additional more than 3 petabytes of storage at CHPC. Similarly, kind of doing upgrades at SKI to increase our GPU compute, our storage, and our networking speed. And our hope is that with these kind of incremental investments that we're able to provide a cyber infrastructure that can support the future of research. So as I mentioned from the beginning, kind of what we're trying to do is to support the regional cyber infrastructure. And so this was a recent NSF award that we had for campus cyber infrastructure, focused on storage, looking at how we can improve our data archiving and disaster recovery. So this is a map of Utah, I think from Colorado. It's not very far, but you can see that we're very spread out. I think that that's common with many of our mountain states, is we're very rural in nature. And so at the bottom of the map, you can see our tape archive, and that's where we're putting our disaster recovery. So very far from Salt Lake, which is up near where you see the U. And so I think that this is really showing that what we're trying to do is build out the storage infrastructure, because data is the future of computing, and making sure that we have access for all of these different institutions as well as other entities across the state. So we have this idea that we want to make the state hub of computing at CHPC. So this includes our repository at the library, our compute, our storage, and integrates well with our disaster recovery that we have also in the bottom right corner. And this ties to all of the local storage and compute at each of the universities across the state. And the important thing is that we're also tying to some of these national cyber infrastructures. So I know Yolanda talked a lot about the NAIR and access. We also have the National Data Platform and the National Science Data Fabric that are at least partnered out of the University of Utah. And so really figuring out how we as Utah can leverage the cyber infrastructure and pay it forward and backward. So for the National Science Data Fabric, this is a project that spreads over the entire United States. We have an entity in the University of Utah, but it's really trying to ensure that we have equitable access to data-driven sciences and that it's not just our high-performance computing centers or data centers that have access to this data. Similarly, the National Data Platform is another project outside of the University of Utah. It hopes to facilitate data discovery through this centralized hub and then democratizes data access through these distributed points of presence or POPs. And really, the hope is that this can help to provide classroom education for K through 12 or higher education, do data challenges, and we're using this to support an upcoming hackathon. So really, as this program develops, and this is a pilot program out of the NAIR, so the National AI Research Resource, really understanding what we can do with this and how this could enable democratized access to both AI and data. Highlighting our kind of statewide data cyber infrastructure, you can see that even though the state is very broad and very rural, we do have connectivity that's provided across a lot of the state. And this is for our educational and telehealth networks. So that's our UEN and UTN infrastructure. But the goal is that we create this network. We leverage this existing kind of networking map to provide integration across cloud services, data repository, compute access, and really be able to make a statewide infrastructure. So part of what we're doing with that is development of a community consortium, working together with people from industry, government, and academia from across the state to look at these various pillars and be able to kind of leverage this combined intellect and really make a partnership that's greater than the sum of all of its parts. We also have a lot of support from the state. So NVIDIA recently made a partnership with the state of Utah, as well as I think 16, but I think it's only 7 of the universities across Utah, but really trying to build up this idea of literacy. So how do we get AI literacy to every person across Utah and beyond? And so this is something that we're doing there. We're also wanted to highlight kind of this unique ecosystem that we have, where we have a very collaborative ecosystem, for the lack of a better word. But we have our Office of AI Policy. This is a state office, so the state actually developed an office specifically to create learning labs and allow for regulatory mitigation. This allows for new exploration in new fields, such as mental health, figuring out how do we use AI for things like mental health. Our Utah State Board of Education, we were the first state to have an AI specialist within our state, within the State Board of Education. And so kind of working together around these principles of responsible innovation, so ensuring that we're thinking about those important things like the environment, public privacy, security. We're also looking at public-private partnerships. How do we work together for this? And then this accessible innovation infrastructure. This is something that's provided both by CHPC, but also through investments at the state level. And so I think it's really important to emphasize the goal of partnerships. I know we got started a little late, but I think I still have time. So I wanted to talk about a few of the science cases that we have at University of Utah. And we have, within our Responsible AI initiative, we were able to award 7 faculty fellows. So these are existing faculty within the University of Utah, bring them into our community and highlight their work. You can see they have badges kind of showing whether their alignment is with environment, teaching and learning, or healthcare and wellness. We also have postdoctoral fellow, Blake Vernon, and then our distinguished visitor program. So we've only had 1 visitor so far, but it was David Danks from UCSD. So Brian Cotting is a professor in anthropology. And so he is maybe a non-traditional user of AI, but he's doing some really interesting work with photography of the Great Salt Lake. So here you can see 2 pictures of the Great Salt Lake, and I don't remember the exact years, but you can see that in the picture on the left, the lake is very broad. We're having really nice water content, and then in this later picture, which is more recent, that the level of the lake has gone down. This is a big concern just due to environmental issues. There's a lot of minerals within the lake that when we have wind provide bad air quality and toxic elements within the air. So one thing he's looking at is using satellite imagery to understand where we might be able to identify invasive species, and then being able to address each invasive species and really understand if we control invasive species within a specific area, how does that affect downstream water? And so this is an interesting use case. And he's also looking at developing soil moisture models from satellite imaging to understand where's our water going and how do we kind of manage that water. And then looking kind of on this right with, I guess, the wheel of life to some extent, looking at what would happen if we introduce specific new species. And so understanding kind of what might impact the success of new species as we try to reintegrate or reintroduce kind of some of our native land practices. Isabel Freiling is a communication assistant professor. She's really interested in how misinformation can affect both the environmental impact and the ability for people to, I guess, take information for granted. And so part of the concern that she has and what's depicted in this image is really we may not actually understand what people are seeing online, so it's very difficult to understand what the impact may be. You can do these very controlled studies in the lab, but that doesn't mimic what we are actually seeing when we're scrolling through news articles or social media on our phones. And so a lot of her work is really understanding both what impact misinformation has on our trust of data and how correction of misinformation may actually impact our ability to recall that information a little bit more. And so it's a very interesting kind of take on misinformation and the potential concerns that AI allows within that realm. Maggie French, she's a PT from our athletic training and physical therapy department. She's really interested in looking at some of this AI approaches for post-stroke care. So one of the things that she noticed is that if you look at outcomes, we don't necessarily see that the value of care is the same for everyone. The outcomes vary drastically. The costs may be the same, or vice versa, you may see similar outcomes with very diverse costs. And so she's looking at trying to use AI to better understand the specifics of where we're seeing a lot of value in the healthcare system. And this is my last example. Cheng Li is another one of our faculty fellows, really focused on teaching and learning from our educational psychology department. He has developed a program that actually leverages a learning-based system that instead of having students kind of learn just through online interactions of providing them questions and seeing if their answers are correct or incorrect, it's actually using an LLM on the back end to act as a student such that the students within the classroom are teaching the AI student. And that has learned, so far it's looked like it's double learning metrics in the classroom, and so this is for middle school math majors. So it's a really interesting way to see how we can use AI to affect students at all levels. And with that, I want to thank you all for listening, and thanks for the invitation. I think it's been a really great day to learn so much about what's going on here at CS or at all of these various institutions. So thank you.
We do have time for questions, but I'm going to ask you to use.
We have time for questions. I'm going to ask you to use the microphone so they can be picked up online. So questions that you might have for Penny. Yeah, Thomas.
Thanks. Hi, Penny. I'm Thomas Hauser, the director of the Computing and Data Lab at NCAR. So one of the questions I have is, how do you want to integrate your kind of library data archive with your maybe AI compute resources? Are there plans to tightly couple that?
Great question. So with our national data platform, currently platform is just being focused on some very unique, like specific data sets as it's in its pilot phase. But I think the goal would be that as we enable this repository, so we have our data repositories, and it could be any data repository, but also ours at the U. The goal is to really be able to have compute as close to the data as possible. And so part of what we're doing there is also providing CHPC resources for folks who are computing on data. So this is, again, kind of that national cyber infrastructure idea, but if everyone can contribute to this and we can have various areas where folks are able to, support both data access and compute, ideally you'd be computing on that data as close to the data as possible to remove some of the issues of data transfer that were discussed earlier this morning. So that is something that we're currently working on, is really just kind of leveraging local compute, but enabling external users to have access to that as well.
Just a quick question, because I love the idea of collaborative data sharing and having attempted to set up some of these collaborations. I think the hardest part is getting, because we've talked about how data is the most important part, is getting people to share their data now that they know the value of their data. I mean, people know value of data, but how do you share it and yet maintain control of data? How have you guys navigated those kind of relationships as you've created this great network?
Yeah, I think enabling data sharing is so critical, and obviously with the federal mandates, there's much more likelihood that people are at least aware of data sharing, but I think that previous to that, there was so much concern that if you put your data out there, then people will do something that you had planned to do. And so what we're trying to do is really enable through the libraries access to both information about what data sharing can do, as well as the ability to share that data adequately such that it can be reused and hopefully reused across domains. But I would say one thing that we've done is just lowering the barrier to allowing people to do that, the upload and reuse and reshare. But I know that there are a lot of other things. We've had a lot of conversations. I don't know, many of you may be aware of the NIHS index challenge that's coming up. I think that we've had conversations about that for a long time, about how do we encourage data sharing, and I think that's something that has to be broader than a single university. I think universities can do things like help you publish when you're sharing a data set, and that's something that we've thought about a lot and have supported it. I don't know, it's a one-off so far, but I think that that's something we definitely want to encourage as well, is enabling that data sharing as an additional publication, because that is kind of the currency of academia. And then beyond that, I think there needs to be a culture where data sharing is thought of as a critical step instead of kind of an afterthought. And I think that's going to be a long-term project that it will take a lot of people to work on, but it's definitely something that we're interested in.
So I have a question, because you provide computing as a service and to both the university community, but also to private users. So what's the bookkeeping? And do you have accounts and charge, and is there a back-end financial model for this? And is it the goal that it's self-supporting?
Yes, that's a great question. So first, I would say currently our model, we have great models with Utah State University. Beyond that, it's been, you have to bring in people as collaborators, and so that's something that we're actively working on with our current project, is enabling it such that everyone can have access without having to go through the University of Utah. So that's the answer to your first question. And then your second question was?
Is it the idea that it becomes self-supporting?
Yes, that's a great question. So within the University of Utah, and actually all of our partners now, we provide free access to storage and compute within reason. People can purchase compute and install that, and then they have priority. But so far we haven't had any issues with competing resources, but I do think that long-term sustainability, it will require funding, whether that's from the state or from federal funding. I think right now our model is not set up well to be self-sustaining without state support, but our state has been very supportive so far, and so I hope that we can continue that relationship because I think it is critical to being able to provide that regional cyber infrastructure.
I will say when I saw the $100 million number, it kind of blew my socks off. Although it looks like it's coming in $5 million a year chunks, is that right?
Well, so the $100 million is for the entire initiative, which a lot of that is actually cluster hires for faculty. And so we currently have about $15 million that is directly allocated for cyber infrastructure, but we are actively working with the state to see if we can build out some state cyber infrastructure. So, yeah, the $100 million seems like a big amount, but somehow it's not. It's still a finite number.
Okay. Well, great. Let's thank Penny once more for the comments.